Hello students, if you remember, in last part we have seen what is meant by heat transfer, how the heat transfer from one place to other place that we have seen. There are three different methods to transfer the heat that also we have looked out in last video. So that are nothing but what? Conduction, convection, and nothing but the last one is radiation. Conduction in terms of vibration of particle, convection in which with the actual migration of particle, and radiation is the form of transfer of energy, actually is in the form of electromagnetic wave. Heat get emitted in terms of electromagnetic wave, and that is the fastest method to transfer the heat, which does not require material medium in radiation. But conduction and convection require the material medium for its propagation. So this part already we have learned. Now what the point remaining are nothing but what? Under conduction there is one point they have given in a book, that is said to be thermal conductivity. That we have to see what is meant by thermal conductivity. So let's start with today thermal conductivity. Before going into detail of this, suppose we have taken a cup of tea, hot cup of tea, and we have put it in the table on the surface of table at a room temperature. It is seen that after some time the temperature of tea get decreases, and maybe it is equal to temperature of surrounding. So where the hot temperature goes, that temperature transfer to the surrounding, or we can say there is a formation of equilibrium, exchange of heat from hot tea to the colder surrounding. Same thing can occur in another way. Suppose we have a ice cream cup we have kept in the surrounding on a table, then definitely it will occur after some time it start melting. It start melting means what? Is temperature start getting increased due to surrounding temperature is greater than the ice cream, exactly opposite to that of tea. So in both the cases of hot tea or cold ice cream, the temperature either changes, we can say changes, it will decrease or increase. In case of tea it get decrease, in case of ice cream temperature get increased because surrounding temperature is greater than the ice cream. In case of tea, temperature of tea is greater than the surrounding, that's why it decreases, and ice cream temperature increases. So where this type of due to change in the material due to temperature, that we have to learn. Again, one of the another best example we have taken, suppose this is a metal rod I have, just I am attaching the flame here and I am holding it here. I have attached the flame means I am heating this rod at this end. After some time you will recognize that this heat get transferred from this end to this end, and our hand may feel some warmness, okay, or our hand may get burn out after some time. What does it mean? The end which we are heating by the flame, that is said to be hot end, and another end, this one which we have hold it by hand, that is said to be cold end. So when you heat this hot end, it is seen that the flame give the energy to this end, and that energy transfer from this hot end toward our hand, that is said to be the heat transfer from hot end to cold end. So after some time our hand get heated, or we may feel some burning due to more temperature. So that is nothing but transfer of heat due to change in temperature of end. This is hot end means its temperature is large, cold end means its temperature is less. Same thing they try to explain you, and it is seen that when we are hitting this end and we move from this part to this part, it is seen that temperature here get changes according to what, as we are moving from this side to that side, it is seen that temperature get changed from this side to this, temperature get changed. Here temperature is maximum, little bit less, little bit less, little bit less. In this fashion there is change in temperature. Suppose we have taken the hot end temperature is T1, this is T1 temperature, this is T2 temperature, and distance between the two end is suppose X. Then you can write the simple formula, that is T1 minus T2 divided by X. T1 is the temperature of hot end, T2 is the temperature of cold end. They are separated by distance X, and this is said to be temperature gradient. Temperature gradient. Why it is temperature gradient? Temperature changes with a distance. If you remember, those who are present for my first lecture, when we have started a unit and measurement, at that time when you see the dimension, at that time we have seen this temperature gradient. So at that time what we have mentioned is dt by dx, change in temperature with the distance, and that is said to be temperature gradient. So to learn about the thermal conductivity much more, we must consider one coefficient of thermal conductivity. Let's start with the coefficient of thermal conductivity. What is meant by coefficient of thermal conductivity? So for this coefficient of thermal conductivity, just point to remember, temperature gradient means what? Change in temperature divided by distance. Change in temperature divided by distance. We have to use this further. Now here in your book there is one figure. They have drawn one figure here, 7.12b. What they have done, they have just taken, just they have tried to draw a cube. Suppose such type of cube they try to draw. I will draw it here. So this is the one side of the cube, this is another side of the cube, and just they have drawn such type of cube in your book. Okay, now they have just given a shaded part to this side. This part is, this side is shaded like this side is shaded like this. Its temperature of this side is T1 they have taken. Temperature of this face of the cube they have taken T2, such that T1 is greater than T2. In the cube it has the 6 faces. Out of 6 faces, 2 opposite faces. This left hand side face has a temperature T1, exactly opposite to this the face has a temperature T2, and T1 is greater than T2. What does it means? It means that T1 face is said to be hot end of the rod, just like a rod, hot end of the cube. T2 is said to be cold end of the cube. Now definitely, as this is hot, this is cold, heat transfer from T1 to T2 because T1 is greater than T2. Now it is seen that how much amount of heat will transfer or flow from T1 to T2. How much amount of heat transfer or flow, that we have to learn here. Suppose heat is moving from T1 to T2, is Q amount of heat is moving. Q amount of heat is moving, and let us suppose this cube has, every side of the cube is x. This is x coordinate, width is x, height is x, and again this is nothing but the breadth is again x. Such type of cube we have taken. So all the sides are equal to x. Then amount of heat transmitted from T1 to T2 is found to be Q, and it is said to be directly proportional to area of the cube. Whatever the area of this faces, the amount of heat transfer from T1 to T2 is directly proportional to Q. Again, it is directly proportional to change in temperature T1 minus T2. Again, the same heat is directly proportional to time. How much time? For how much time we are just going to transfer the heat? So it is directly proportional to time also. So how much time we are passing the heat? So it is directly proportional to that time. Q directly proportional to 2, as well as this amount of heat is directly proportional to 1 by x, or it is said to be inversely proportional to distance. If you combine all this, you can write a simple equation. This heat Q is equal to what? You can write A into T1 minus T2 into small t divided by x. Q is directly proportional to all these quantities. Now I have removed the proportionality sign. We can take equality sign with some constant of proportionality, that is k we can say. Remaining terms are as it is, A into T1 minus T2. These are temperature, small t is a time, and x is a distance. Then this equation, in this equation, this k is said to be coefficient of thermal conductivity. K is said to be coefficient of thermal conductivity. Now in this equation, suppose we have kept this area is 1 meter square, change in temperature is 1 degree Celsius, and this time is 1 second, suppose distance is 1 meter, suppose, then you can say Q must be equal to K. When this Q is equal to K, amount of heat transfer from hot end to cold end is equal to coefficient of thermal expansion. When the area is unity, change in temperature is 1 degree Celsius, time for propagation of heat is 1 second, and distance which it will travel is 1 meter, then we can say Q equal to K. That is, coefficient of thermal expansion is equal to amount of heat transfer from hot end to cold end. Same thing they have done in your book. So accordingly, you can just give the definition of this. According to this, you can give the definition of thermal conductivity, coefficient of thermal conductivity. So let's read it from your book, page number 135, left hand side and right hand side. Both times they have just given the definition of coefficient K. In 2 definitions they have given. Let's start with the first. So coefficient of thermal conductivity of material is defined as quantity of heat that flows in 1 second, quantity of heat that flows in 1 second between the two opposite faces of cube kept at a 1 meter distance apart and temperature difference of 1 degree Celsius. Just see the same from the diagram. The amount of heat transfer coefficient of thermal conductivity of material is defined as quantity of heat transfer from one phase to opposite phase kept at a distance of 1 meter apart for a unit amount of time with a temperature difference of 1 degree Celsius. Then that amount of heat transfer from this phase to this phase, that is said to be coefficient of thermal conductivity. Now further, just try to derive the equation. So I will rub this part. I will write the next equation to this side. So if we see, we have written this equation here, Q equal to K into this. Just from this equation, find the value of K. So what is K equal to? K equal to X goes up. So Q into X divide by A into T1 minus T2 into small t. This equation gives the value of thermal conductivity, coefficient of thermal conductivity. So that they have given in your book, equation 7.35 that we have drawn here, Qx divided by A, T1 minus T2. From this equation, just we have find out the value of K. It comes like this. Apart from this, if you see from this, what is the SI unit of coefficient of thermal conductivity? Amount of heat is measured in joule. Okay, this is in meter, this is meter square. We can write like this. This as Q is measured in joule, distance is in meter, area is in meter square, temperature is in degree Celsius, time is in second. Now in this case, if we see this meter get cancelled with this meter, what is the unit then? Joule per meter per degree Celsius per second. Or we can write this as joule per meter square per degree Celsius per second is a unit for this coefficient of thermal conductivity. If you take temperature in Kelvin, then this would be per Kelvin. Remaining things are same. Joule per meter per Kelvin per second. These are the unit for measurement of this coefficient of thermal conductivity. Apart from this, if you see, just these are the unit we have drawn from this formula. So here again, just from this equation we have derived this. So in this equation I can modify this again. Suppose this T I have shifted to left hand side. What we get here? Q divided by T. This T is shifted here. Equal to what? K into A into T1 minus T2. Small t is already shifted. Divide by X. So this equation we can write. Now in this equation, this term Q by T, it was represented by power radiated, or we can say power conducted per time, per unit time. How much heat transfer per unit time? Amount of heat transfer per unit time is said to be power conducted power, that is represented by P conducted. So COND they have represented, and is equal to K A T1 minus T2 divide by X. This much amount of power is conducted. We can represent it like this. Now here, this power conducted means this Q by T, or this P conducted, power transmitted or amount of heat transmitted from one phase to other phase is Q by T, that is P conducted. It was measured in watt. It is measured in watt. So this formula of this can get modified further. Unit of coefficient of thermal conductivity can be just modified further, and that can be written as watt. That can be from this formula. If you find a K again, K equal to what? This into X divided by A into T1 minus T2, and accordingly then you can just find out the unit watt per meter per degree Celsius. W for watt per meter per degree Celsius. This is the unit for the coefficient of thermal conductivity in degrees Celsius. If you take Kelvin, it comes to be per Kelvin, meter per meter, and this is W for watt. These are the units for this K, coefficient of thermal conductivity, which are different from the initial one. Why they are different? Because in this case, this Q divided by T, this equation, this Q divided by T, that was measured in watt. So you can modify this unit. Initial unit is also right. This is also the modified unit. Both the units are accurate for this thermal conductivity. Now here we can write one equation for this in general. In general, from this part, this equation, you can write one equation here that I will write. I will erase this part. Okay. So from this you can write this as in terms of small change dq by dt. dq is small transfer of heat in small time dt. dq by dt equal to this k, this a with a minus sign, minus ka, and this t2 minus t1 divided by x, it is dt by dx. Now if you remember, this dt by dx is what? Temperature gradient. Just we have seen at the starting of this topic, this temperature gradient. And now here the minus sign is what there? It is in that because here